You know what? We are going to do the member function calls here. So everyone stay tuned for the member function call implementation. Alright. So the idea behind supporting the member function calls is pretty easy. For this we need this pointer, and we just say that this pointer will be part of every function call, whether it has this pointer or not. And this makes the handling of this expression, which points to this pointer, into a generic thing. So let's do that. Whenever we start putting in parameters for a function, so we know how many parameters can be given to it, then we call begin parameters, and we call end parameters. And after we call end parameters, the parameter list for a function is done. This means the next free thing, the next parameter, is this pointer, right? What we can do is just note this, right? So we add a thing into our state that represents this pointer. I think we should have this somewhere. This, yeah, here. The BC value is this, right? The BC value this gives us what this pointer would be, right? And this is what we set, right? On end parameters, we say gen parameter and we assign this to it. Gen parameter, right? I told you type. Oops, type. As always, because all pointers have to be of this type, right? We could also say actually we can't. So we have to say if be this, if we have this variable expression, right? We do this. We say to be type of me.be this dot type, right? And if that succeeds, I think it always has to succeed or else it would bail out. So yeah. Then we can do this. Then we can set the variable and we'd be done, I think. Yeah. Yeah, I think so. Yeah, this should actually be all we need to support this pointer. And we give ourselves the possibility of parsing one in all this. Or past this. Right? Okay. For later. Now let's see if we can still build. Alright, this is all small, right? Oh yeah, this. It's the same here. Again, export is not callable. 2792 91. There we go. Yeah, this of course will not work. The return value will simply be this, right? There we go. Alright. Now we better write a test file. And we do this. Function. Let's declare struct outside. Struct. Let's do something nice here. Iota. Or let's just call it iota. Right, and then we do end step. Current. Yeah, then we do front. Oops. We just return current. So how long has to go there? And then we have from the text no parameters, and this is current plus equals step, and we have bool empty, and this will just return current smaller than and right. And the constructor which we do actually we have multiple constructors which are all pure. Three ones actually. And this is end, run step, and then end. Or we could have this and step. And begin. And step. There we go. Our step is usually one, right? So third step has to be greater than 0. Actually step just has to be not equal to 0. Those don't have to be unts, they can be ints. Right? We cannot have a step of 0. Cannot have a step of 0 because then we never go anywhere. Right? Yeah. Then yeah. We say this step equals step. This dot current current equals begin, and this dot end and equals end like this. Now when doing iota, and for this we simply do let's return array. Actually, no. This actually returns the range. So this is the struct. So this is the range. Iota, that's the initializing function. Then returns iota range. And let's say this just takes an end, and we just specify an end here, and then you auto sum to current and this just says for each iota of end, for each number in iota of end, end result plus equals n, turn result. There we go. Say pragma message sum to 200. This should work. Test this call. Gives me a completely erroneous number, which leads me to believe that iota does not give me valid range, or that it's empty immediately. So it's empty when current is bigger than end. Yeah. Alright. This seems to work. So now let's see what happens when I do this. The same happens, alright. Check the timing. No improvement, because we don't do this calls at the moment. We have to enable our debug our bailout messages to see if something goes on. Which we have now done. And sure enough, it says we can't do the method calls, which is true. Alright, what do we do now? We go in here. We go to 4141. And we try to to make this work, right? And we can't use underscore this for this because this is the old this, right? Instead we have to do instead we have to do we have to gen xbar dve.e1 which should be the this expression, if I'm not completely mistaken. Let's just check what it is, right? So we import ddds type name, and then we say right then dve1, and we say dve.e1 the toString, and we have a space in between, maybe with 2 dashes so we can distinguish it, and then we say st type name. We can just say dve.e1.ast type name, so we know what type it is if we need to do more with it. Alright? Now we remake our DMD and compile the same thing, and we need to import std.stdo. dve.e1.ac type name was the one here. And we just import std.stdo. And check this, and dve.e1 is a var expression. Okay. And this variable expression is __r53. Okay. Yeah. So the E1 is really the thing we want to iterate over. We should see this if we get the type of this. dve.e1 dot what was it? Alright. Now that we know that this is a var expression, we can do this. Let's say we do this so we know if something goes wrong. Oh, I think we can get the type directly. I'm not sure. This would be the var type, right? Um, then we get the type of that. And this should be the type iota struct thing we just made. No property var for that expression in 4143. Ah yes, we have to include the karst in here, like that. Yes, you can see here the type is the iota range we defined in test this call. Oops, no, of course. Here, the iota range. Good, so far so good. So we know our thing. Okay. This means we need to alloc a variable of that type and set the variable we have to this. So now actually at this point we should already have a variable of that type. We have to have a variable that is that thing. So let's check if we can get it. This is the thing we need. And we want to see if we can get this. And this better be a variable declaration. Oops. There we go. So we need the AST type now of that as well. Dot var. Otherwise we can't be sure, right? If it is a variable declaration, but I think it is. Oh yeah, right, we can't do the right then actually. There we go. Now it is a var declaration. Okay, that's good. Now we don't need this, and we can cast this to a var declaration. If GMD complains, it will most likely say what's the right type name for this is, but it seems I typed it incorrectly. So now we should be able to see what it is, what we can get there. Nothing. Oh yeah, because we commented this line out, which we shouldn't do. So we do indeed get a stack value of type struct that is at the stack address 12. This is probably pointer to the struct we need. Which could actually be bad. Because now it's not parameter, which is strange. Maybe we should rewrite it. And make it 1. Or we should just pass this value as parameter. At this point it'd be great to see what code was generated until we hit the bailout, and for that we have a very handy thing, the printer backend, which can show us the bytecode that was generated. So we do make a 0. Then we call something with our parameter 1. Which is 0. This creates the struct. We set 12 to 1, which we allocated for this pointer. We generate a label for some reason. Make it another temporary. No, this is something we shouldn't do. We store the result of this temporary compared against 0 inside itself, So this is a Boolean. This is just really a Boolean, which we use to jump unconditionally. Then yeah, we do this add. Then we jump to label 1, which is here. Where we then check if this is still true. But in the meantime, like, we should have modified this value in the meantime, because otherwise it can never ever get true. And currently it's in a state where it can never ever become true. This is fairly disconcerting. This here calls the first function that we generated. Yeah, this is tricky. This is why this calls are hard. Let me pause the video and come to it back later. Okay. This temperature value here, which is the condition, the Boolean condition we jump on, never gets modified because it would be modified by the call we do, right? In between here and here, we would normally do a call, but this call never gets emitted, right? Because we can't do the call to empty. You see that the call to empty is the first call we attempt, and this is the thing we do here. This call here is the constructor getting called. That's the iota constructor call we do here, and you can see that take the first parameter of our function, and this is what we call the constructor with. Alright, and if we now allow the member function call to succeed, the method call to succeed, right? By doing the call just as we would do normally. Then we'll still see nothing because we return here. So now we should get a bit further, and maybe we'll actually see the call to empty, which will change the value there. There doesn't seem to be call emitted because we can't deal with closures. Because it checks if fd.need this is there. So we remove this temporarily. To see if we can emit something, and we see that we can't. Now we have to see whether this thing sec false. And sec false and end parameters. Probably because we have no function declaration to work on. Is this the case? Like, where could we sec false and end parameters? Oops. The only place where we could segfold is if we wouldn't have a me. Right? If the me isn't set. That means we have to assert that we have a me. Which is probably where we will fail, yes. This is assertion failure in 1510, and this will probably be the me, right? Yeah, it means we have no me at this point. Which is pretty bad, actually. So, what do we see there on the stack trace? So evaluate function. This is the outer one. This one should set the me. Before it begins the parameters. At this point we already have a me, so yeah, after clearing, say begin parameters, we set a new me right after beginning. Or probably even before beginning, we set the me, which was cleared. It should not need to be set here. Now we should have me, which we can consult for this pointer. And we'll see that this now works. And now we see that it makes a new temporary for the result of this call, right? Which is calls without parameters. And it checks it against 0 and stores that in temporary 2 and jumps on that. This is the call to empty. right? I hope you can see that. This is the call to empty, which it uses to check if it should continue this loop here, right? So, let me go there and inject our this pointer, which should be here. This should be stack address 12, right? Which we already got. Like, we got this when we tried to get the thing. So method call, right? We already got this variable. So this is our this pointer, right? So, so we do auto this pointer. Yeah, we have to. No, actually we don't. Well, yes, we have to define it outside. So this is BC value this pointer, right? When we are here, we can set it, right, to the variable expression we got, right? Yeah, actually, we can do a gen expression on that, which should give us the same thing. Right? Then we don't bail out on the method call, but what we do is this. We after all our things are done, right? We put into this pointer. I think we called it this pointer up here. Yes, we did. So after this is done, this is if we have this pointer. This makes use of the automatic conversion, which we can do here as well. If this pointer then we set it. Alright. And we should then be able to call it and you can see that we call this with this pointer we obtained using this constructor call here. But it still doesn't work because we can't return structs in iota here. But if that weren't the case, it would work actually. Temporary 5 has a void value, which is actually true, because this is the pop front call, which we just call, and then jump to label 1. And what does the conditional jump 1 do? And we jump here if this is false, and then we return, then we end the function. And the first thing we have here would be the constructor. Which allocates a value of 0, which is definitely not correct. And it stores all zeros. Which is also not correct. Like, it should store the parameter in one place. And it totally doesn't. It wants to call another function with the parameter. Oh, this is the default construction. Yeah, this makes sense actually. But then it aborts before it can do that one as well. Otherwise it would construct 5 functions. Yes, that would be what happens. So this is the default construction. After the default construction is done here, it calls the real constructor here. So yeah, this would work. Here you can see this. It calls this with a parameter, with 0 and with 1. When we go to the node to the test this call file, you will see that this is exactly this. The parameter, then 0, then 1. This is what is being done there. So this is the call to iota. And iota does that. it initializes a temporary iota range object and then uses this to call this call on here. So yeah, and you can see that it passes here the this pointer. This is the this pointer to that object. It parses that as temporary one function one. Temporary one function one is an I32, which is the memory we allocated here, right? And it returns that. And it returns it as a type of a struct. So yeah, we would have to see what this function 6 turns out to be, but I think it will just be like this. It will just do a bunch of stores, then return the parameter that was given here. And yeah, that would be the constructor call, which seems to work. This is very, very encouraging, and it looks like that this calls will be done later this week. I'm going to stop this recording and do an upload. Whoops, there we go.